right, so now that we know how the graph is going to be affected in words, we're actually going to take the next step and we're going to figure out how do the points themselves, individual points that were on the parent function, how do they change? And so we're going to use this acronym BCAD, Black Cats and Dogs, as a mnemonic device to remember the order in which the functions happen, okay, and what values A, B, C, and D, what do they affect? So I have this handy little table here, so let's describe what this means. Okay, so I took a little T-chart, okay, and I put the B and the C on the left, okay, and I put the A and the D on the right. This column right here, okay, the left-hand column, I'm describing for you, okay, that the X coordinate, if I'm talking about an XY coordinate, an X comma Y, that the X part of the coordinate is affected by B and C, okay, and the Y part of the coordinate is affected by A and D. So the way that we remember that is BCAD, Black Cats and Dogs. We know that BC affects X, AD affects Y. Okay, so that's the first thing, is what do they affect? Okay, the second question is, how do each of those values affect X or Y? Like, what operation am I going to use when I know the C value or the B value? So that's what the second row is talking about. They're saying, okay, you're going to take the B value and you are going to multiply by, remember, the reciprocal of B. Okay, you're going to multiply the reciprocal of B by the X value, and that's how you're going to change it. Then you are going to add or subtract the A value, or sorry, the C value on the X or the Y number. Okay, and then we're going to switch and we're going to go to the Y coordinate. And we're going to say multiply by the A value, add the D value. Right, so that's what this expression is doing. And usually what you'll end up seeing is on the top of quizzes and tests, a lot of times people will make a very quick version of this that just says X and Y, and we do B, C, A, D, and then mama, M-A-M-A. And so this is how we kind of very quickly summarize all of this information that says that B affects X using multiplication, and again, remember that's by the reciprocal. C affects X using addition, but remember it's the opposite of what you see. Okay, A affects Y using multiplication. D affects Y using addition, right? So we have to take kind of remember all that stuff. This is our handy little chart to do that. So let's use this and see how that effect actually happens. Okay, so if I give you this function 4 comma 5, okay, and I'm saying on this point, there's again we have this random function f of x, and there's this point 4 comma 5, okay, and I'm taking a look at each of these different functions. I'm saying these are different ways that I could transform the original function, doing slides and reflections and stretches and all of those things, right? And we want to know, where is 4 comma 5, that specific point, going to end up when I do all of these transformations? So let's start with the first one. The first one, it has only one transformation happening. I have this 2 out front. 2 is an A value. So if I go back to my chart again, it says that A is only going to affect the Y coordinate, and I'm going to multiply by the A value. So here's what's going to end up happening. I'm going to take my original point, 4 comma 5, okay, and what that chart tells me, which let me write it over here again in its shorthand form, I have X and Y could be changed, okay, B and C are going to affect only the X value, A and D are going to affect only the Y value, okay, B affects using multiplication, addition, multiplication, addition. So here's what this is saying. Because I'm talking about an A value, that's what 2 is, I'm going to say, okay, A is only going to affect the Y coordinate. So that would be our 5. So what I know is that the 4, which is the X coordinate, is not going to change at all. I don't have any B values or C values to make that change, right? So what I'm going to say is that's not changing at all. So I'm saying the Y is definitely going to change, but now I need to think about how is it going to change. And what my handy little chart here is telling me is that I'm going to use multiplication by the A value to change the Y. So in this case, this is saying take my 2, multiply it by Y. The result, okay, is where that point is going to end up. So if I do a vertical stretch by 2, which is what this A value is doing, 4 comma 5 is really going to turn into 4 comma 10. Okay, that's where that point's going to end up. Okay, so let's do the same thing. This value right here is a C value. Okay, that's C. So again, if I come over to my table, what it's telling me is that the point 4 comma 5, okay, has a C value, and this thing says use the C value, add it to the X coordinate. So my C value is again 4. So be careful. I know you see on the paper -4, but remember it's always the opposite of what you're seeing because of the way that the function's written. Okay, so I'm going to add 4 to my x value because that's what this says to add c to x. So that 4 is now going to become 8. I don't have any a's or d's, which means the 5 is going to stay exactly where it is. Okay, so 4 comma 5 is going to slide to the right and become 8 comma 5. So we're just applying these 4 notions to the function, okay, until we're done. Okay, we've used up all of them. So if I were to look at this one, I'd say this has an a and a d. So let's do the function. This one's going to have 2 steps because I actually have 2 different transformations happening. So my first transformation, I'm going to look and say, okay, a and d are both on the y side, so they're both only going to affect the y. So it's still again going to be 4 comma. I'm not going to change x at all. Okay, so it says first look at the a and multiply by it. So I'm going to take my 5, multiply it by -3, and I'm going to turn it into a -15. So I'm going to put a little extra value here, and I'm going to say this is a transformation by a. Okay, and then I'm going to do another transformation because I have d, and this says add d to y, but I'm going to add it to my already transformed y. So -15 plus 1 is going to turn this into 4 comma -14. So if I take this function f of x and I have 2 transformations a and d, 4 comma 5 is going to move all the way over to the left to 4 comma -14. Okay, or all the way down to 4 comma -14. All right, so let's talk about the last one. I got one more. Okay, so 4 comma 5 is my starting point. I have 3 transformations. I have an a value. Remember, this is -1, okay, because of the negative there. Okay, I have a b value, which is 2, but I'm going to remember right away before I do anything else that 2 I'm actually going to care about the reciprocal of, which is 1/2, and then I have a d value, which in this case is -3. So those are the values that I'm going to use to do this transformation. All right, so let's go across the list. I'm going to start off with b. I do have a b value, and what it says is to multiply by the reciprocal of b and use the x coordinate. So I'm going to take the x coordinate and I'm going to multiply it by 1/2, and it's going to become 2 comma 5. Okay, so that's a b transformation that I just did. Okay, and now I'm going to keep going. I'm going to do another one. I'm going to say next on my list there is no c, so I'm not going to do that one. Now I'm going to move over to the y side, and I'm going to look at a. A says multiply a by y. Well, a is -1. So this is going to turn into from the 2 is going to stay the same. The y side is going to go from 5 multiplied by -1 would make it -5. Right? So again, that was just doing the a transformation. Right? And I have one more, and that is add d to y. So if I add -3 to -5, my final point is going to be 2 comma -8, and that was a d transformation. Okay? So again, the idea here is we can specifically say that the point 4 comma 5 after all of these transformations is going to end up very specifically at the point 2 comma -8, and we can do this for all of the points that we want that we graphed on the parent function and actually get a very accurate graph of what the newly transformed function is going to look like.